Doing things graphically and drawing vectors of forces sometimes makes problems really easy to solve. So for example, like a satellite problem. We'll have the satellite spinning around the Earth, and its momentum I've drawn here, so it's changing directions. And I know for that case, dp dt perpendicular is p omega, and this units of force. And I know dp dt perpendicular is the net force perpendicular. So just doing that tells me net force. And then if I have a case where the velocity is constant, dp dt parallel is dp dt, the magnitude doesn't change, so that's 0. But for solving that problem, that's really not important for this case, because things are vectorial. So dp dt perpendicular is this, so that we know that's our net force. Think about a free body diagram of this system. Let's draw it maybe at this point right here. What forces are acting on it? It's only gravitational force. It says units. So if I think about it graphically, as I'm spinning around, dp dt is always pointed inwards. So that's my net force. And at every point I'm my gravitational force. And that's the only thing that's acting, so therefore net force has to equal gravitational force. So you can see on the top view, I know here's net force, gravitational force, and this net force perpendicular, because that's the only net force I have for this case. That has to equal there. So I can, net force is p omega, dp dt. Yeah. dp dt perpendicular is p omega. Gravitational force is this. I know v is r omega. Omega is this. I can substitute in for omega. Get this. Those are the same. Mass of the satellite doesn't matter. Divide by an r, I get this, and so there's my velocity of satellite. Real easy, and thinking about things vectorially helps me, and actually drawing them helps me understand the problem.